if we return to the 8 effective teaching practices, I'm wondering if anybody thought about these 2 vignettes in light of the 8 effective teaching practices. Well, let's do that. So, he established clear goals for learning. That was the very first practice. And you can really see how he was using the goals to frame the questions he was asking. I mean, goal 1 was about students would be able to write equations that showed the relationship between the 2 quantities. So like in group 1, what he was trying to do is to get them to move beyond simply counting the total number of tiles, because that was never going to allow them to generalize. And goal 3 was to make connections between symbolic and pictorial representations. So every one of his questions to both groups was, how does this relate to the picture? And when he visited the second group the second time, they actually weren't working on what he had asked them to work on. They had gone to x squared plus 1, and he brought them back to say, no, when I left I asked you to do this. So there was an accountability. I am holding you accountable for what we had talked about. Now there's nothing wrong with x squared plus 1 if they could have related it to the picture. But that wasn't what he wanted. He didn't want them to abandon their first strategy. He wanted them to think about why that made sense in the context of this problem, which of course it does. He selected a task that promotes reasoning and problem solving. There are multiple paths into this task. It was a good task. There isn't an algorithm to solve this task. So you really have to think about what's going on here. What is the underlying structure of the pattern? And how can I use that to determine what a bigger one's going to look like? And of course, it was all about making connections between the pictorial, in this case, and the symbolic. And as I heard many people say, I mean, if you look at the transcript and you start highlighting things, all he did was ask questions. He didn't really tell them anything. But his questions were of a particular type. I would say there were 2 kinds of questions. One was, he was trying to figure out what it was they understood about the problem and about what they had done. So I would call those assessing questions. He was trying to assess what it was students understood and to sort of clarify exactly what was going on. And the next thing he did, once he understood where students were, then he asked questions to move them beyond where they currently were. And I would call those advancing questions. So his whole interaction with the group involved assessing and then advancing them, and then returning to see what progress they had made on the advancing question. So if we return to the effective teaching practices, we've just talked about goals, tasks, representations, and questions. I'm going to give you a little bit more of information to convince you that he was also doing some of the rest of these that may have been a little bit less obvious. So, how about meaningful discourse? You know, he did a lot of question and answer with the group. I'm not sure I would call that meaningful discourse. What happened at the end of this lesson is he identified 4 different groups, 4 different solution strategies, and he invited the student, a student from each group, to come to the front and explain what they had done. So I'll get back to say more about this in a minute. But group 1, that's the very first group we saw, the one who initially just counted, and then came up with x squared plus 1 and couldn't explain it, actually explained the rectangle with the 2 squares. And then other groups explained the other things. So what you've got is the teacher who was keeping track of what students in the room were doing so that he could actually invite students to present in a way that sort of sequence the solutions in a way that students could actually access the descriptions even if they hadn't produced it themselves. And then during the discussion, Ziegler facilitated by asking students to make connections between the physical arrangements of tiles and the symbolic. And he asked students from groups other than the ones who produced the generalization. He pressed students to discuss the equality of the equations. So again, how are all these things related to each other? That was his goal too, the whole notion of equivalence. And finally, he had them explain why the function was not linear. So you might be scratching your head, and I think after the first clip you might have been saying, was this really productive? Well, I'm going to argue that struggle is productive if the intended goals and the cognitive demand of the task are maintained. So what does that mean? Did the teacher accomplish what he set out to do? Did he reach the destination that was what he had in mind when he started the lesson? And did the cognitive demands refers to the thinking potential. Did the thinking demands of the task, were they maintained? Did students actually have to engage in thinking and reasoning in order to do this? And certainly from the small portion we saw, the answer is yes. He didn't tell them what to do. So how did they come up with those 4 solutions? So the students' thinking is supported by acknowledging effort and mathematical understanding, and students are able to move forward in a task execution through their own actions, as opposed to being able to move forward because the teacher told me what to do. So now I want to go back and revisit Group 1. So Group 1 was the first, we saw them, they were the first group featured in the first clip and the second group featured in the second. So when we started, all they could do was count. Then on the second visit, they'd come up with x squared plus 1. So the students continued to struggle to find a way to relate x squared plus 1 to the figure. But through their efforts, they found a different generalization that stemmed from the physical arrangement of tiles. So when Ziegler visited them a third time, they had abandoned x squared plus 1, and they had come up with the rectangle plus 2. So this is a group that at the beginning of the class was counting the number of tiles in each figure as the only way to come up with it. And now they had come up with a generalization that they could actually support. And this is simply a transcript of the student presenter who explained what their work had been. So I would argue that this provides evidence, certainly, of Group 1's productive struggle. They really struggled through this, but they came out of it with a solution to the problem. Were rewarded for that by presenting it to the whole class. And so the question then is, okay, this lesson probably took like an hour, and was it worth the time spent? I would argue that it was. The students were able to figure something out on their own without being told what to do. So let's look at evidence of student uses, elicit and use evidence of student thinking. That was the last practice on the list. So again, elicit student thinking has a lot to do with asking questions that make student thinking visible and gets it on the table. And using it is, now that I understand what it is students know, I'm going to use this to move the student forward. So in the lighter purple, we see the teacher really trying to ask questions to figure out what they know. And then leaving them with a question that's going to push them beyond where they are. An example from Group 2. So basically, he said, show me, tell me, and they just were like, wow, told them everything they could about the problem. So then he comes back and he says, okay, So I get what you now know, and he's not arguing that this is a correct or incorrect solution. In fact, it was correct, but they couldn't explain it. So he's using what they know to press them to go further. So one way I've come to think about these is supporting productive struggle, which is number 7 on the list there, is only done through bringing most of the other practices to bear. So here we see clear goals for students' learning, a task that promotes reasoning and problem solving, using and connecting different representations, facilitating meaningful discourse, posing purposeful questions, and eliciting and using evidence of student thinking. So supporting productive struggle doesn't happen in a bubble. It happens because you're doing all of these things. That's what's supporting the struggle. Now, the one I did not mention is building fluency from conceptual understanding. This wasn't a lesson about fluency, but it was a lesson about building conceptual understanding, about relationships, about linearity, what it looks like, what it doesn't look like, how you know when you have it, and so on. So, I would argue that Ziegler is what has been referred to in the literature as a warm demander. And warm demander has been described as somebody who knows the culture of students, has strong relationships with students, and commands that everyone within the classroom will be respectful and follow classroom norms. A warm demander takes deliberate action to build relationships, learn about students' cultures, provide clear and consistent expectations, and communicate an expectation of success. What you notice is he seemed to have a good relationship with the students that we saw him working with. They weren't happy when he walked away, but it all seemed fairly friendly. But he had very high standards. He didn't let them off the hook when he came back, and they hadn't done what he asked them to do. So I think this notion of warm demander is a really interesting one to think about. Because when kids know that you really care about them, they are more likely to be willing to work hard. And I see some of you nodding. There's also a lot that's been written lately about identity. And this research by, can't do the names very well. Anyway, these 3 individuals suggest that students' identities as mathematical learners are affirmed by promoting persistence and reasoning during problem solving, encouraging students to see themselves as confident problem solvers who can make valuable contributions. So taking somebody from a group that struggled for half of the class period and then inviting them to come up and explain their solution to the class is really acknowledging the hard work that they did. Assuming that mistakes and incorrect answers are a source of learning, explicitly validating students' knowledge and experience as math learners, and recognizing mathematical identities as multifaceted. So what I mean by that is, when you have a problem where you can do different things, where you could build, where you could draw, where you could make a table, where you could make a picture, where you could come up with symbolic representation, there are some kids who might be better at some of those pieces than others. But making it clear that being good at mathematics doesn't just mean being able to get the right answer every time you do a computation. So the ability to think and reason through a situation and valuing different kinds of contributions. So, you don't have to read this. What I'm going to do, though, is Ziegler actually, last year I interviewed him trying to get a better understanding of his whole view about developing identity. So I'm actually going to play you an audio and this is just a transcript of that, and you can hear in his own words his view of this.
When did you find yourself shaping into the person that says, you know, I really love math, I think math is exciting, I think math is fun? Or that person that says, you know, I really kind of get that pit in my stomach when I have to come to math class every day. But there's a reason for that. Something happened along the way. Something happened multiple times that got you to this point. What was that? Because, you know, it's my responsibility to continue to shape their math identity. So if they really love math and they really enjoy math, so it's my responsibility to challenge them, but to hopefully keep them in that space. The students that come in struggling or, you know, really disliking it, how do I create an environment, a space, a year in which helps reshape that or form it in other ways that hopefully when they leave, you know, they're not just saying, I love Mr. Ziga's class, or I thought this class was great, but that math, that I really got a new insight on what mathematics is and how I really do mathematics and how much fun it can be.
I think he's being pretty realistic there. He's not saying, I expect everyone to leave this class like thinking math is the greatest thing since sliced bread. But I want them to all be able to make some progress and see that they can do mathematics. And I'm sure you all have had students that part of what you're facing is trying to get them to engage in the work and develop more confidence in themselves. And let's face it, by the time you get to high school, you can feel pretty beaten down by what has happened to you in the years that preceded it. So, although you may only have a student for 1 year, what can you do within that year to help them become more confident, to develop more of an identity? Because we know if students decide that they're done with mathematics, it has serious implications of what they're positioned to do beyond high school.